This is part 6 in the series on cheap electronics kits, and in this video we'll be looking at this. This is of course a multimeter, and it's in kit form. In fact, this is I think the third or fourth attempt I had to buy one of these. This one eventually turned up as a kit, but all the previous ones which were advertised as kits turned up, but when I opened the box, what was inside was a fully complete unit, so it wasn't any good, and or at least not for what I wanted it for. And eventually I got hold of one that was actually a kit, so just be aware of that if you do try and buy one of these. I purchased this off eBay. Total price was £9.90 delivered. Now I appreciate you can buy these ready-made for less than that. You can buy other multimeters for less than that. But this is a kit, so really what it's aimed at is enjoyment of building something. And in this case, in theory at least, you end up with a working multimeter. Now this is not going to be a full review of the multimeter. I'll do a few comparative tests if it works when I finish assembling it. But this is really about the fun factor of the kit itself. So that said, let's dive in, see what's in the box. So I haven't opened this yet, just had a quick look to make sure it was actually a kit. So it is a kit or broken. Okay, that's all that's in the box. Some very useful information there. But I think it does come with a schematic, so it's always interesting to look at the schematics on these. Very simple designs that you can get, and most of this is really about the switching, which is of course just a function of the PCB layout. But quite reasonable. Obviously it's just based around the 7106 IC. Can't see anything spectacular in there, so let's have a look at the kit itself. So cheap but reasonable quality. It's actually slightly better than I was expecting. Very nicely laid out components, although maybe a bit annoying trying to get them out of here. Maybe overkill, but yeah, if it's for beginners, then that may well be a very good thing. It can also help teach you the color code for resistors. Okay, so this is obviously quite a developed design, because we've got chip on board, and the actual quality of the board itself seems to be quite reasonable. It's quite a thin board, and I'm a bit concerned about this point here. If we're not careful, we'll end up snapping that off. But other than that, it does seem to be quite a nicely made board. As ever, all the holes are the same size, so I assume that they might be a bit on the large side for the resistors, but we'll see how it all goes together. Okay, and we've got the LCD. Uses I assume a zebra strip to connect to the connector on the board. Quite a nice quality front cover there. That's the overlay. Quite nice and bright and clear, so it's quite good. We'll have a look in the bag. Okay, so quite a collection of parts. And it's going to be a bit of a puzzle putting this together. We can't really look at the instructions. You can possibly download some instructions for this, but I'm not going to do that. I'm going to assume it's Christmas morning and the internet's down, and I want to get on and build this. So, okay. We'll start as usual with the resistors. and as I said, the first thing I'm a bit concerned about is the footprints for the resistors seem to be way too small, so I'm just going to try and figure out exactly how these are supposed to go on. It's possible they should be mounted vertically, but I'll just need to check to make sure there's enough space inside the case to actually do that. I don't want to assemble it and find there is no way to put the entire thing together. So I'll try that, I'll get the resistors fitted and then get back on camera, and we'll go from there. Okay, so that's the resistors fitted. The board is marked with the values and they do coincide with what's on the card for the most part. The only discrepancy I found was there are two 9K resistors. One's marked on the card as 0.5% and one as 1%, but they were actually both 0.5%, so it didn't really matter which one I fitted where. Now, whatever this board is plated with, it definitely is not gold. This is probably the worst board I've come across with regard to soldering. It seems to be coated in something that is anti-solder. It just does not like accepting solder. It would not flow. I had to crank the iron temperature up to 360 degrees before I could get it to solder at all. And as I say, it's the worst I've come across, so that lets the kit down a little bit already. Part of the joy of making these is in soldering the parts on, and when that task is difficult or more difficult than it should be, then it takes a lot of the fun out of it. Having said that, all the parts did fit. They do stand up vertically and there is plenty of room in the case to do that, so I checked that before I soldered them in. So the next step is to get the capacitors fitted. I'll fit the diode as well, and then we'll go from there. Okay, that's the capacitors and the diode fitted, or at least all the capacitors apart from two. These don't fit on the board, they're too big, so that's a bit of a disappointment. I'll dig some out that are the correct values and will fit on the board. You probably could manage to sort of bend the leads and force these in, but I'll just find some that are the right size. They're only 160N capacitors, so I'll find something a bit more suitable. And whatever this coating is on the PCB is, I think they've sacrificed durability of the switch for solderability. At least I hope that's what it is, because it is absolutely terrible to solder, and it's a big disappointment. It does mean that there's no way you could recommend this for a beginner. It's just too difficult to solder the components. But we'll continue anyway. Next step is to get the preset and the test sockets soldered to the board, fuse holder, and then the final thing will be to assemble the switch and see how it all goes together. There's also a shunt that needs to be soldered on here as well, so I'll do that, and we'll go from there and see if we can then get it to all slot together. Okay, so that's the current shunt and the preset fitted. I've also fitted the test socket. I've made sure that the little tab on the test socket lines up with the notch on the front cover. So next step is to get the fuse holder fitted. Because it mounts on the opposite side where the switch is, they've had to use a surface mount fuse holder. So easiest way to fit these, if you haven't done this before, is to get the fuse holder, fit the fuse into it, make sure it's sitting flat, and then of course you can hold that onto the board and solder it in place. If you don't do that, you'll end up with the contacts skewed and not lined up properly, and it'll look untidy and you won't be able to get the fuse in properly. Okay, so once I've done that, the next step will be to figure out how the contacts fit, whether they go all the way into the board or if they need to be set at certain heights. So I'll check that against the case and see how that lines up, and then it's a case of trying to figure out how the switch all assembles. Okay, so that's the fuse holder fitted. I've also fitted the terminals. I haven't soldered them all the way around yet in case I need to adjust them, but it does appear they go all the way into the board, so they sit flush once the board is mounted into the case. The next thing I need to fit are the battery terminals, and I think they just slot through the board like this and get soldered onto the two terminals here. I'll do that later. I want to try and figure out how the selector switch is assembled first. So looking on the inside of the front cover, we've got these kind of notches here, which I think are for the positional indents for the selector switch. And looking on the selector switch, the forward facing lip or flange has got these two recesses, and I think that's for these two small springs and a couple of small ball bearings, which are used to give the switch some feel and some centering action in the correct location. So the next thing is to try and figure out how the terminals go onto this. Now, I've had a look at this and I'm pretty sure that they go on across these little ridges. I think it's a case of putting them on like that. There are 6 in total, and I think there's one for each of these ridges, and then it is just a case of fitting this onto the board and putting a central screw in. So I'll do that next and see if it all fits together, and if it seems to line up with the contacts on the board. Okay, so I've got the contacts fitted to the knob. There doesn't appear to be a screw that holds all this together, which is unfortunate. It will make assembly a bit of a faff, but I think the next thing we have to do is fit this into the case, and so we need to fit a spring and ball into each of these recesses. And then fit this into the case without losing the 2 balls. Okay, and so the next thing is to put the LCD into its recess. So that will fit in here. Just checking which way up it goes. Okay, so we need the live edge at the bottom. Make sure it's clean. Pop that into position. Then fit the zebra strip. Okay, it doesn't go all the way along, so I need to make sure I'm spanning the portion that's going to need to make contact, which is there. And now I need to put all this together without it all disintegrating into a pile of pieces. So pop this into there. Just trying to make sure I don't dislodge the zebra strip as I do this. So it still seems to be there, and it seems to be in the right place. Then I need to hold all this together and put the 4 screws in. So we've got 2 large screws, 4 short, and I'm going to fit the battery contacts out because I'm not quite sure where they're supposed to line up, so I've left those off for now. I do have access to the portions I need to solder. Like I said, if I solder them in the wrong place, then they won't make contact with the battery. Okay, so the next thing I have to do is put the screws in that hold this board in place. Okay, it's not too much, it's a bit stiff, but I suspect this would really benefit from a bit of silicone grease on the underside, so I may take it apart and do that if it works. But the next thing I need to do is grab a battery, solder the 2 contacts on, make sure they line up, and then we can try and power it up. Okay, so I've got the battery contacts fitted, and the next thing I'm going to do is fit the front overlay. So it's just a case of peeling the backing off, making sure it lines up, and then pressing it down into place. Okay, well, that fits in there quite nicely. Okay, well, the next thing to do is get a battery and see if it will actually come to life. Okay, I've got a battery. We'll try fitting this and see if the meter actually works. Okay, well, that's the battery fitted. Next thing to do is we'll turn it on and see what happens. Well, it's a good sign. Not quite sure what HV stands for. That's resistance. I would have expected an overrange reading at that point, but we'll see what it does later. Okay, well, what I'll do, I'll get set up and we'll do some comparative testing against the bench multimeter. It's not a particularly fair test, I know, but we'll see how accurate this is. There is a specification of sorts in the document that came with it, so it's saying what appears to be saying is millivolts, volts, and it's giving us about 0.5% plus or minus 2 digits for DC volts, and 1% plus or minus 2 digits for current, 1.2% plus or minus 10 digits for AC volts, and 0.8% plus or minus 2 digits for resistance. So we'll do a few tests with this and see how accurate it is, and also figure out what the adjuster's for and adjust that if necessary. I still haven't fitted the 2 capacitors yet. Looking on the schematic, they will be needed for proper accuracy, so I'll fit those before we do any comparative testing. And the only thing I'd say so far is that it was a bit of a frustrating kit to assemble with regard to soldering. Actually assembling it was quite fun, but the soldering of the board was a bit of a pain, and certainly not something I would recommend for a beginner. Having said that, the kit overall so far it's reasonable for the price. It's better quality than I expected, and we'll just have to see how well it works. Okay, so I've got a bench multimeter set up along with our new test meter. Got them both connected to the bench power supply so I can apply various voltages. I'm not going to do a full test of this or in-depth test, and no, this is not the correct way to set up to do accuracy testing on anything or a multimeter in particular, but I suspect this will easily be accurate enough for this particular unit. I'm using some test leads here just to make the connections easier, but the meter does come with its own set of test leads, and they are surprisingly good quality. It's quite nice soft test lead wire, so that is quite nice. Not particularly long, but they're certainly adequate for the cost of the unit. It's even got shielded ends at the meter end. Quite nice sharp probes. They actually feel quite nice, so a bit on the small side, but certainly quite adequate for something of this cost. I'm not expecting a great deal from this, but let's see how well it performs. So we'll turn this meter on. I'll set it on the 20 volt range, and we'll turn the bench supply on, which is currently set to 1 volt. It's only going to give us a nominally correct voltage. It's not. I'm not using a voltage reference. I didn't think it was really necessary for testing this. And as you can see, we're getting 0.98, and the specification for voltage, if you recall, was 0.5% plus or minus 2 counts. So that is indeed within spec. So really needs a multi-turn pot on there, but okay, so it's now reading a lot closer than it was. Go up to 20 volts. For the next range. Change to 30 volts. Go to 100 millivolts. And back to 1 volt. Okay, so you can see that the resistors that are used are not really adequate for this, and I think the specification they're giving on here is more to do with the tolerance of the resistors that they've used. So if you wanted to, you could of course change the resistors for 0.1% or better if you wanted more accuracy, but with a meter with this limited count, it's probably not really worth it. It's only meant as a very cheap meter, remember, it's not going to be ultra precise. Okay, so on volts it's not too bad. It's certainly adequate if you're just using it for very basic testing and you don't need anything particularly precise. Then it will more than likely do. It will certainly do for very cheap and cheerful testing. Okay, so the next thing we'll do is set up for resistance and see how accurate it is in measuring resistance. Okay, I've got a 1K 1% resistor connected, and looking at the Agilent first, it's showing us 992 ohms or thereabouts. So remember that, 992, so let's go to the new meter, and it's showing us 982. So again, not too bad. It's actually more precise than I was expecting. I'm not sure precise is the right word to use, but it's not as inaccurate as I was expecting. And as I said, I'm not going to do a full review, I'm just doing one or two values here, so not looking too bad. We'll try a 10k resistor and see how that fares. Okay, this is 10k 1%. And it's showing us 10.05. Okay, so about the same sort of error and still well within a usable tolerance. It's not going to give us ultra precise readings, but it's easily accurate enough to be of some use. So I'll change the setup and we'll look at the current accuracy. Okay, so a setup for current. Switch it on, it should be around 100 milliamps. So we're getting 100.2 on the Agilent and just under 100 on our little multimeter. So again, not too bad. We'll go down to 10 milliamps. So I mean the error is fairly consistent as we go up and down, and probably about what we'd expect. We'll go down a bit further. So around 1 milliamp. So it's now showing us in microamps. So increasingly inaccurate as we get to smaller values, but that's to be expected with this type of unit. And you can see the readings are also getting very noisy, so again that's to be expected with something like this. So we'll go up a little bit and we'll go up to the 10 amp range and see what it shows us. Okay, so we'll try 1 amp. So reading quite high. So this is just down to this shunt is obviously not the right length. If you want to, you can adjust this by moving the shunt in and out, so just desoldering or melting the solder on one end and moving the shunt in and out of the board to adjust its effective length, and that will adjust this, as will putting solder onto it. So if, for example, it was reading way too high, what you can do is put some solder onto the shunt, and that will effectively reduce its resistance. But in this case, because it's reading high, what we can do is just melt the solder and push the shunt a bit further into the board. So I'll try that now. I'll just go and try and shorten the effective length of the shunt and see if that has the desired effect. Okay, I've adjusted the length of the shunt slightly by heating up the solder on the board where the shunt soldered and pushing the shunt slightly further in. It's looped up away from the board. You probably can't see it that well, but I've heated both ends and pushed it into the board slightly. That makes its effective length less and so reduces its resistance, and because we were reading high, it should bring us a bit closer to the correct reading. So switch the supply back on. We're still set to 1 amp, and as you can see we're now much closer. Slightly too short now, so I may lengthen it very slightly. We'll try 2 amps. So not too bad, much nearer than it was. It was reading 1.13 at 1 amp, and it's now reading 0.9899. So quite close. It's nothing compared to a high quality meter, of course, but very cheap and cheerful. Okay, so I've fully assembled the unit now. I've put the back cover on, and it feels quite nice. It's got quite a nice weight to it. It's a very nice stiff case. It doesn't sort of flex and bend and creak like a lot of very cheap meters, so it actually feels like it might survive more than 20 minutes in the workshop. The connectors are also quite nice, quite a nice fit. The test probes fit quite nicely. They don't rattle about and wobble all over the place, so that's quite nice. The switch is, I've had worse switches on quite expensive meters. This has got quite a nice positive feel to it. It's a bit on the tight side, and I suspect that if I took it apart and put a bit of silicone grease on it, that might really help, so I may well do that. And as I said, I will do a follow-up video if any of the testing I carry out reveals anything interesting. But in terms of whether I think it was worth the money I paid for it, the only negative thing I have to say about this really is that the quality of the plating on the PCB is terrible. It makes soldering it very difficult, and for that reason alone I would not recommend this to a beginner. Having said that, the kit was reasonable in terms of its assembly quality. The rest of the assembly, all the parts fitted quite well. The instructions are probably fairly useless. They don't really tell us anything. Usually there is online information you can download about these, and so in short, is it worth £9.90 that I paid for it? And I think the short answer is probably no, it isn't. You can buy these ready-made for probably half what I paid for this, and because of the aggravation in trying to assemble the board, it probably takes a lot of the fun out of it. So it's a bit of a shame really, because that's probably the only negative thing I would say against it, but it is quite an important thing for a kit aimed at beginners. It does need to be reasonably easy to solder. That's where a lot of difficulty can arise, and without quite an expensive iron, I think this would be quite difficult to assemble. Other than that, I think it's quite a nice unit. It's not particularly accurate, but it is good enough for what it's for, and if they can sort out the quality of the circuit board, it would be quite a nice kit.